In section 4.1, we talk about systems of linear equations in two variables. So the first thing is a solution to a system of two linear equations in two variables is just an ordered pair that is a solution to both equations. So let's go ahead and try this with example number 1. We're going to determine whether 3, -2 is a solution to the system. So the first thing that I like to do is I like to label the equations in my system so I don't get confused with which one I'm working with. So looking at equation number 1, we've got x plus 3y equals -3. We want to plug in our ordered pair of 3, -2. So that's 3 plus 3 times -2 should give me -3. Well, 3 times -2 is -6, and 3 minus 6 is -3. And so I got a true statement. And we want to do the same process with the second equation. 4x plus 3y equals 6. So we have 4 times 3 plus 3 times -2 equals 6. And 4 times 3 is 12, and 3 times -2 is -6. And 12 minus 6 is 6, which is definitely a true statement. And so this means that 3, -2 is a solution. And so we have 3 different methods we're going to look at. The first method is graphing. We don't use this method that often because it's hard to sometimes get an exact solution off of a graph. So let's go ahead and look at the system. 2x plus 3y equals 12 and x minus y equals 1. So again, I'm going to label my equation so I know which one I'm working with. So equation 1, we have 2x plus 3y equals 12. Let's go ahead and solve for y and put this into slope-intercept form. So we're going to subtract 2x from both sides. And so it cancels on the left. And we have 3y equals -2x plus 12. And we want to divide by 3. So we get y equals -2/3 x plus 4. And so my y-intercept is the point 0, and my slope is -2/3, which means I can go down 2 units, into the right 3, or I can go up 2 units, into the left 3. So let's go ahead and plot this equation first. So we go to 0, 4, and then we use the slope to find the next point. Now let's go ahead and do the same thing with equation number 2. X minus y equals 1. So let's go ahead and subtract x from both sides. And so we get negative y equals negative x plus 1. And then we can divide by negative 1. And we end up with y equals x minus 1. And so my y-intercept is the point 0, negative 1. And my slope is 1. Or we can write this as 1 over 1. And so we can go up 1 unit and to the right 1. Or we can go down 1 unit into the left 1. So plotting 0, negative 1 first. We use our slope of 1 over 1 to find our next few points. And then we go ahead and connect them. And so wherever they intersect at is going to be the solution to the system. So we can see that they intersect at the point 3, 2. And so that's going to be the solution. The other two methods that we're going to use, we can do algebraically instead of drawing a graph and estimating. And so the first one is the substitution method. So first thing you're going to do is you're going to solve for a variable in one of the equations. If possible, pick one with a coefficient of 1. You're going to substitute whatever variable you solved for in step 1 into the other equation. You're going to solve the second equation for that variable. You will substitute this value back into any equation with both variables to solve for the second variable, and then you're going to check the solution in both of the original equations. So let's go ahead and use the substitution method to find the solution to the following system. So again, I'm going to label my equations. And so equation number 2 is already solved for x, which means we can plug 2y minus 5 into equation 1 wherever we see an x. So looking at equation 1, we have 2 times, now we know x is 2y minus 5 plus 4y equals negative 6. We want to make sure that we distribute the 2 to both pieces. And so we get 4y minus 10 plus 4y equals negative 6. We can go ahead and combine like terms. And we end up with 8y minus 10 equals negative 6. Now let's go ahead and solve for y. So we are going to add 10 to both sides. And so we end up with 8y equals 4. And then dividing by 8. We end up with y equals 1/2. And so now that I have solved for one variable, I can plug it into any equation that I want to figure out x, the other variable. So I'm going to plug this into equation number 2 since it's already solved for x. And so what we end up having is x equals 2 times our y, which is 1/2, minus 5. Well, these 2's end up canceling and we're left with just a 1. So x equals 1 minus 5. And 1 minus 5 is negative 4. And so that means the solution to our system, remember to put it in the correct order, is negative 4 comma 1/2. Let's go ahead and try a little bit more of a complicated one. So again, I want to label my equations. And the first thing you should do is get rid of those ugly fractions in equation number 1. And so to do that, we need to find the least common denominator. And so the least common denominator is going to be 4. And that's what we need to multiply every single piece by to get rid of the fractions. And so the 2 and the 4, we can take a 2 out. The 4's are going to end up canceling, and they're going to cancel again. So our new equation 1 is going to be 2x minus y equals negative 3. And so let's go ahead and solve this for y so that we can substitute it into equation number 2. I'm going to subtract 2x from both sides. And it doesn't matter if you solve for x or for y. It's just y has a coefficient of negative 1, so it's a little bit easier. So we have negative y equals negative 2x minus 3. And then we want to divide by negative 1. And so we get y equals 2x plus 3. We are going to plug 2x plus 3 into equation 2 wherever we see a y. So we have 3x minus 2 times, we're going to have 2x plus 3 equals negative 6. We're going to distribute the negative 2 to both pieces. And so we end up with 3x minus 4x minus 6 equals negative 6. We can combine like terms. We end up with negative x minus 6 equals negative 6. We can add 6 to both sides. And so it actually ends up canceling on both sides. And so we end up with negative x equals 0. And when I divide by negative 1, we're still going to get 0. And so now that I have one of the coordinates, I can go ahead and plug this into any of the equations to figure out the other one. So I'm actually going to plug this back into the equation we solved for y. Because it's already solved for y, it'll make things easier. So we have y equals 2 times 0 plus 3, but then that's just 0 plus 3, which is 3. And so you always want to make sure that you put these in the right order, and we end up with the point 0, 3 as our solution. The next method we have is the addition/elimination method. So the first thing you want to do is arrange each equation in the form ax plus by equals c. You're going to multiply one or both equations by appropriate numbers so that the coefficients of one of the variables are opposites, which means one is positive and one is negative. You're going to add the two equations from step 2 together so that one of the variables is eliminated. You're going to solve the resulting equation for the remaining variable. You'll substitute this value into one of the original or equivalent equations and solve to find the value of the other variable. And you check the solution in both of the original equations. So let's go ahead and try this out. Again, I always want to label my equations. And so looking at these two equations, I can see that x, I have 1x and I have negative 1x. So if I were to add these together, then they would eliminate. And this is perfect. That's exactly what we want to happen. So we don't need to multiply, we just need to add these together. So we have x minus 5y equals negative 12. And then we have negative x plus y equals 4. And so we're just going to add these two equations together. So x plus negative x is going to cancel. Negative 5y plus y is negative 4y. And negative 12 plus 4 is negative 8. And so now we just need to divide by negative 4 on both sides to get y by itself. And so it cancels on the left. And we get y equals 2. Well, now that I have y equals 2, I can plug it into any of these to get the x that we're looking for. So let's go ahead and plug into equation number 2 just because it looks simpler. And so that's negative x plus 2 equals 4. Well, when I subtract 2 from both sides, we end up with negative x equals 2, and dividing by negative 1, we get x equals negative 2. And so putting them in the right order, we end up with the point negative 2, 2. Let's go ahead and try something a little bit more complicated for example number 6. So the first thing we want to do is let's go ahead and get rid of the fractions for both of these sets of equations. So let's look at equation number 1 first. We've got x over 4 plus y over 6 equals negative 2/3. And we need to get rid of the fractions, and so we need the LCD. What would be the LCD in this case? Well, the LCD between 4, 6, and 3 is going to be 12. So we need to multiply each piece by 12. And so when we end up doing this, 4 goes into 12 3 times, 6 goes into 12 2 times, and 3 goes into 12 4 times. So we end up with 3x plus 2y equals negative 8. So that's the new equation number 1. Let's look at equation number 2. We've got x over 5 plus y over 2 equals 1/5. And so my LCD in this case is going to be 10. So we need to multiply every single piece by 10. And so 5 goes into 10 twice, 2 goes into 10 5 times, and 5 goes into 10 twice. And so what we end up with is 2x plus 5y is equal to 2, and this is my new equation number 2. And so now we need to decide, do I want to eliminate x or y? So I have a 3x and a 2y and a 2x and a 5y. So I'm going to eliminate x, but it doesn't matter which one you pick. And so I need to make 3 and 2 look the same, and one of them needs to be positive and one needs to be negative. So I'm going to multiply my new equation number 1 by negative 2 so that I can get negative x. So we end up with negative 6x minus 4y equals 16. I just multiplied every single piece by negative 2. I'm going to multiply equation 2, my new one, by 3 so that I can get positive 6x plus 15y equals 6. You always want to make sure that you multiply the constants by the number as well. That's the part that most people forget. And so now that one of my variables has opposite coefficients, we just go ahead and add them together. So negative 6 plus 6 is going to cancel. We have negative 4 plus 15y, which is 11y, and 6 plus 16 is 22. And so dividing by 11 on both sides. We end up with y equals 2. And then remember, we can plug this into any equation we want to. I don't suggest plugging it into the fractions. I suggest plugging it into one of the modified equations that we did on the left-hand side. So I'm going to plug this into equation number 1, the nice version of it. We've got 3x plus 2 times our y, which is 2, equals negative 8. And so 3x plus 4 is negative 8. We can subtract 4 from both sides. So we get 3x equals negative 12, and then dividing by 3, we get x is negative 4. And so we just want to make sure we put this in the correct order. We've got negative 4, 2 as our solution. So in general, the system of equations may have one solution, no solution, or an infinite number of solutions. And so we've looked at a bunch of case ones where we had one solution, and graphically it's where they intersect at that point. For case 2 with no solution, graphically what that means is that the lines never intersect. So they're parallel lines. And for case 3, an infinite number of solutions just means that I have now graphed the line twice, right on top of each other, which it intersects at every single point on the line, and there's an infinite number of solutions on the line. And so that's what this green box says. One solution is the two graphs intersect at one point, which is the solution, and we say that they are independent. It is a consistent system of equations, and there is a point or ordered pair consistent with both equations. No solution is the two graphs are parallel and do not intersect. We say that the system of equations is inconsistent because there is no point consistent with both equations. An infinite number of solutions, the graphs of each equation yield the exact same line. Every ordered pair on this line is a solution to both of them, and we say that the equations are dependent. So let's go ahead and try one more system here. We've got 0.5x minus 0.2y equals 1.3, and negative 1.0x plus 0.4y equals negative 2.6. So let's go ahead and label our equations. Now, in order to get rid of the decimals, what we can do is we can multiply both of them by 10. All that does is it moves the decimal one place to the right. And so that's how we're going to start. Let's go ahead and multiply equation number 1 by 10. And so what ends up happening is the decimal of each term is going to move to the right by one place. So we end up with 5x minus 2y equals 13. And you can plug this into the calculator and you will get the exact same thing. For the second equation, we're going to do the same thing. We're going to multiply by 10 so that everything moves to the right one spot. So this is going to give me negative 10x plus 4y equals negative 26. And so this is a lot easier to work with. I want to be able to get rid of one of my variables. I have a 5 and a negative 10, and I have a negative 2 and a 4. Either one is going to be pretty easy to get rid of. So let's go ahead and multiply equation number 1 by 2 so that we could get rid of our x's, because I'm going to get a positive 10x and I already have a negative 10x. So I'm multiplying equation number 1 by 2. It's going to give me 10x minus 4y equals 26. We are going to leave equation 2 exactly the same way and not touch it. And so we can see that our x's are ready to be canceled because I've got a negative 10x and a positive 10x. And so those cancel. But wait a minute, negative 4y plus 4y is going to cancel, and 26 and negative 26 cancels. And so on the left-hand side, everything cancels, which means we have a 0 left over. And on the right-hand side, again, we're left with 0. But 0 equals 0 is definitely a true statement, and it's always true. And because it's true and everything canceled, that means we have an infinite number of solutions. So what this means is it's the exact same line graphed twice, right on top of each other. Now, had the variables canceled and we got a false statement, something like 0 equals 3, then that would be no solution.